Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. My name is Muhammad Fateh Faid bin Anwar and my matrix number is MA24124. So I'm the first presenter from the Group 7 Introductory Six Sigma BMM 3731. So today we are glad to introduce to you guys our group project, which is minimizing inefficient electricity consumption in UMPSA student hostels. Okay, without wasting so much time, I'm going to present to you guys the introduction for our group project. So this the primary purpose of this project is to systematically identify, analyze, and baseline the electricity consumption inefficiencies within the UMPSA student hostels. So to achieve a rigorous data-driven solution, this study utilizes the Six Sigma methodology, which is a highly disciplined process improvement infrastructure that focus on minimizing operational variability and eliminating the process defects. While the complete Six Sigma methodology relies on the five-phase define, measure, analyze, improve, and control, or as known as DMAIC cycle, the objective of this project is strictly anchored within the execution of the first two stages, which is the define and measure phase. Okay, so let's move on to the project charter. As shown in this slide, our project name is Minimizing Inefficient Electricity Consumption in UMPSA Student Hostels. So this project started on 9 June 2026. The area of focus for this project is to reduce electricity wastage and improving the energy efficiency in UMPSA student hostels. So for the business case, this project aims to minimize inefficient electricity consumption in GMPSA student hostels by applying the Six Sigma DMAIC methodology. The excessive energy usage due to unnecessary operation of lighting, air conditioners, fans, and other electrical appliances has led to increase the electricity costs and environmental impacts. For the project scope, number one is to focus on electricity consumption in selected UMPSA student hostels. Number two, we are going to collect and analyze electricity usage data. And lastly, we are going to identify the major sources of energy wastage. Move on to our problem statement. Electricity consumption in UMPSA student hostels has remained higher than expected over the past few years due to inefficient energy usage. This includes lights, fans, and air conditioning units being left switched on when rooms are empty. These habits contribute to increased operational costs and unnecessary energy demand. Therefore, this project aims to identify the root causes of electricity wastage and reduce inefficient electricity consumption by at least 20% through the implementation of Six Sigma methodology. So our goals for this project is to reduce inefficient electricity consumption in June-based student hostels by at least 20%. Number two, to identify the key factors contributing to electricity wastage and improving students' awareness of energy conservation practices. I would like to show to you guys the timeline for our project that includes the milestone and date as shown in this figure. Okay, so let's move on to the team members. We have Firdaus as the project leader, followed by Fateh, Darwish, Rajauddin, and Daniel as the team members. So for the financial part, that includes budget summary and investment. Number one, we have energy monitoring equipment that costs RM 3,000. Number two, we have awareness campaigns materials that includes brochure and poster. It costs RM 1,000. Number three, we have data collection and analysis tools that cost RM 1,500. And lastly, we have energy efficiency improvement initiative that cost RM 4,500.
Assalamualaikum, my name is Muhammad RAJAUDDIN. For the next part, I will explain about the project impact evaluation, which is the first one, society. For the first point, increases student awareness of energy conservation, which is students become more aware of saving electricity. And the next point encourages responsible electricity usage among hostel residents, which is students learn to use electricity wisely. And the next point, automated controls reduce reliance on user behavior, which is automated controls switch off unused light and fans. And the next point ensures all students contribute equally to energy saving effort. All students help save energy through the same system. And the next point helps create a more sustainable campus environment, which is less energy waste help protect the environment. So for the next part, which is economy for project impact evaluation. The first point is reduces hostel electricity bills and operational costs, which is less energy use means lower costs. For the next point, which is minimizes energy wastage caused by inefficient usage, which is prevent unnecessary electricity consumption. For the next point, which is save approximately 30,050 kilowatt of electricity over 6 months. About 30,050 kilowatt can be saved in a 6 month. For the next point, which is addresses the 61.5 percentage energy inefficiency rate identified in the study, which is it can be help reduce the efficiency rate found in the study. And the last point, which is cost saving, can be reinvested into student facilities and sustainability initiative, which is save money can be used to improve the student facilities. That's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Dawshafdi bin Ahmad Daud. Okay, for this part, I will explain about the solution in the dimension of sustainability. As you can see, the solution can support the long-term energy conservation, which is aligned with the SDG 7 by reducing the unnecessary energy consumption. This point can be seen through the projects focused on improving energy efficiency and reducing wastage through the energy controls. Okay, for the next dimension, our report can bring solution to the health and safety. This is by reduce the risk of electrical overloads, overheating, and equipment misuse. And this also can create a safer hostel environment. This point by can be supported by the unauthorized high voltage appliances that contribute 28% of energy wastage and increase the electrical loading. Thank you.
Moving on to the legal frameworks dimension, our project ensures that UMPSA's demand-side management initiatives remain fully compliant with national energy regulations. This project directly aligns with Malaysia's Efficient Management of Electrical Energy Regulations 2008 or EMEER, which mandates that large institutional consumers systematically eliminate energy waste. Currently, the hostel relies on manual student compliance, which our data proves result in an average 61.5% inefficiency rate. By transitioning to engineer controls like PIR motion sensors, we establish an automated compliance framework. This not only satisfies internal university sustainability guidelines but also sets up the required statistical baseline for UMPSA to meet formal MS-ISO 50001 energy management standards. And finally, looking at the environmental impact, our Six Sigma approach answers the core prompt regarding ecological pollution and carbon emissions. Our team's measurement phase uncovered a baseline wastage of 13,050 kilowatt hour over a 6-month period. Our Pareto analysis isolated that 46% of this waste is driven simply by lights and fans running in empty rooms. By implementing our automated sensor and timer solutions to eliminate this specific defect, we prevent 13,050 kilowatt hour of unnecessary power from being drawn from the grid using the national grid emission factor of 0.6 kilogram of carbon dioxide per kilowatt hour. This demand-side management strategy directly prevents approximately 7,830 kilograms of carbon emissions from entering the environment, directly fulfilling the core targets of UN SDG 7.
Okay, so now we move to the next part, which is summary. Before that, my name is Muhammad Firdaus bin Sudi, and my matrix number is MA24127. So, based on our summary, our project charter targeted a 20% reduction in electricity wastage across UMPSA student hostel to cut operational costs. Through high-level SYAFIQ mapping, we successfully isolated the hostel ideal state as the exact boundary where useful energy turns into financial waste. To pinpoint the root causes, our Pareto analysis evaluated six wastage defects. The data clearly isolated the vital few drivers, lights and fan left on in unoccupied rooms recorded the highest wastage at 46%, while clock ventilation fans were the lowest at 2%. In the major phase, our cause and effect matrix, which is CNE, ranked inefficient electricity consumption as the top output variable with 640 weighted score. Our FMEA pinned down unmonitored room equipment as the highest baseline risk, hitting a critical risk priority number of 567. However, by implementing automated PIR motion sensors, we project this risk to drop dramatically to an RPN of 42. Statistically, our baseline consumption data is normally distributed, averaging a mean of 2,175 kilowatt per hour and standard deviation of 650.19. Our Ranchat proof the process is highly stable, falling comfortably between our upper control limit of 4,125.58 and lower control limit of 224.42 with zero special cost variation. Because our CP and CPK indices are both exactly 1.0, our process perfectly spans specification limits, translating to a short-term 3 sigma performance, which is 99.73% as separate, and a long-term 4.5 sigma level, 93.32 as separate, after accounting for a standard 1.5 sigma. Okay, so we move to the last part, which is conclusion. So, based on this project, we can conclude that by successfully executing the rigorous define and measure phases of the DMAIC methodology, we have structured a complex behavior and mechanical problem into a data-driven engineering framework. The study directly advanced UMPSA commitment to sustainable resources management, aligning with UN Sustainable Development Goal 7 for clean, affordable energy and a standard demand-side management protocols. Quantitatively, our finding validated the Pareto 80 over 20 rule, proving that a massive 74% of all hostel electricity waste is driven exclusively by just two behavioral flaws, which is lights or fan left on in empty rooms at 46% and unauthorized high wattage personal appliance at 28%. Over our 6-month monitor period from January to June 2026, this behavior accumulated a total recorded wastage of 13,050 kilowatt per hour and a steady baseline inefficiency rate of 61.5%. Because our normality testing has successfully validated all prerequisite statistical assumptions,
This project is fully primed to advance into the upcoming analyze, improve, and control phases of the Six Sigma life cycle, transitioning our campus from behavior dependent manual switches to automated engineering controls with permanently flattened peak demand cycle, lower institutional utility expenditures, and establish a repeatable milestone for campus wide environmental sustainability. That's all. So I think that's all from our group. Thank you so much.